Okay, so I think I'm almost done talking about Chapter 7. I think I'm just going to do a couple of the Chapter 7 exercises before I give you homework out of Chapter 7. I am about to do 7.9. Here it is. Use Fermat's little theorem to find a number between 0 and 12 that is congruent to 2 to the 100 modulo 13. In other words, we're going to reduce this, and we're going to use Fermat's little theorem. Let me remark, before I even embark on this, I could do this by the repeated squaring method, the method that I showed you. I think we found the last digit of 7 to the 100th power, meaning we reduced 7 to the 100th mod 10. And I could do this one the same way, by the repeated squaring method. Maybe try that at home if you want to see that you get the same answer. Our instructions for this one are to use Fermat's little theorem, though. So what would Fermat's little theorem say? It says that if, oh boy, can I remember? Yeah, if B is not congruent to 0 mod P, and let's just understand that when I write P, I mean a prime here, then B to the P minus 1 is congruent to 1 mod P. Okay, so how would we use that for this? Well, the modulus is an extremely important number, so let's look there first. For us, that's 13. Oh, look, 13 is prime. So what would this tell us? And maybe it looks like B could be 2 because B is like the base number. So if I check, first of all, if B is 2, I'm supposed to check 2 is not congruent to 0 mod 13. Indeed, it's not. If I do 2 minus 0, that's not a multiple of 13. Great. So 2 to the 12th is congruent to 1 mod 13. Okay, well, that's great, but I want 2 to the 100th. How can I do that? So what I would like to do is I would like to build up 2 to the 100th out of things that I know. And let's see. Maybe the best way to do this, actually, let me keep this simple. If I do 2 to the 12th, there's 12 2's. Now I'm up to 24. Now I'm up to 36, 48, 60. I'm definitely not doing this the most efficient way, but this won't take that long. Now I'm up to 72. Now I'm up to 84. Now I'm up to 96. Yeah. And that would be 2 to the 100th. Maybe, like I was saying, I definitely did not just do that the smartest way. Maybe the smarter way would be to do 12 into 100. 12 goes into 108 times. 8 times 12 is 96, and then that's 4. So it goes in 8 times with a remainder of 4. That's why I had 8 of these, and then a 4 left over. Anyway, whichever way, yeah, I guess, let me make it clear what I'm doing. Yeah, so this is 2 to the 12th to the 8th times 2 to the 4th. either way you do it. But so the point is, 2 to the 12th is 1 mod 13. That's why I was separating out all these 2 to the 12th, because this is painful to write all of this, but after I write it, like, every single one of these is just 1. So the only thing that matters is this 2 to the 4th. So now we're down to a much smaller number, and we can do this kind of however we want. Actually, the 2 to the 4th is so small, it's 16. Right? So ultimately, this would be congruent to 3 mod 13. Right? Because the question said our final answer should be a number between 0 and 12. In other words, this is what we typically call the remainder when you divide by 13. We would expect that to be a number between 0 and 12. So there it is. We got it. And I wanted to do another one. 7.17b. Okay. So here's 7.17. This is about proving that n cubed plus 5n is divisible by 6 for every natural number n. I don't know if you remember or not, but we already did a proof by induction for this fact at some point. We're going to do part B, though, now. We're going to use modular arithmetic. So, prove that n cubed plus 5n congruent to 0 mod 6 for all n natural numbers. Okay, so let me show you how a standard proof along these lines goes. This is going to be a pretty mechanical proof. Meaning once you get the idea of what I'm doing, it's just going to be sort of going through the work. So where are we? We're going to check 6 cases. N could be congruent to 0 mod 6. And I can tell you what the other cases are going to be. N could be congruent to 1, or 2, or 3, or 4, or 5. That's all the possibilities. Every natural number n is congruent to something from 0 to 5 mod 6. And that's what we call the remainder. Whatever the remainder is of n divided by 6. It's got to be one of the numbers from 0 to 5. And we're just going to run through all the cases. And let me check the first one. I get to just put in zeros. That gives me 0. And I got it. It's congruent to 0 mod 6. Let me check case 2. N could be congruent to 1 mod 6, in which case n cubed plus 5n is congruent to 1 plus 5, which is 6, which is congruent to 0 mod 6. And in fact, maybe I'm too lazy to actually finish all of this. How about you can check n congruent to 2, 3, and 4. These are an exercise for you. Just take, 2 cubed plus 5 times 2 and check that that's congruent to 0 mod 6, and then 3 cubed plus 5 times 3. You're just checking each one. And let me maybe jump to, oops, I guess this would be case 3, case 4, case 5. I'm forgetting my Roman numerals here. Case 6 is VI, and that would be n congruent to 5. Let me actually show you a little bit of a shortcut here. 5's a big number. Well, okay, I sound like a real baby saying 5's a big number, but we have to do 5 cubed, and maybe I'm too lazy to do, 5 cubed is in the hundreds, and then I have to add something. I would prefer to deal with smaller numbers if I can. If n's congruent to 5, then n's also congruent to -1. Right? If 5 minus -1 is a multiple of 6. So if you're willing to deal with negative numbers, which is sometimes a good idea, it's more pleasant than dealing with big numbers. I would rather deal with small negative numbers than big positive numbers. This is actually much easier because -1 cubed is not a big number at all. And I just do this n cubed plus 5 times n. That's -1 plus 5 times -1, which is -6, which is 0 mod 6. So we're done, assuming that you actually check these 3, so I encourage you to do that, but they do work. So you should check that they work, and check that you can actually, check that you know what I'm doing. Like, check that you can actually get 0 by plugging each one of these things in. So, yeah. And then, so I'll upload these videos and then some homework for you.